Okay, students, it's crunch time. Let's see how you do E10.5 one-step conversions. You're going to need your mole road map and a calculator and a pencil, and I'm going to use colors to mark my given and wanted. All right, so I'm always going to do the given in green and the wanted in pink. Okay, so you can stop this at any time, but I'm going to go through it for you and help you out here. All right, so first question, how many grams of lithium are in 3.5 moles of lithium? The one that is the given is the one that we already know the number. So that's going to be 3.5 moles, and this time it's lithium. And the question we want to know, so the wanted, is how many grams. So wanted and given. All right, we always start with the given over to the left. We copy exactly what we see here, 3.50 moles, and then it's nice to put lithium too. Times, always a fraction comes next. Now to figure out the fraction, or the conversion factor we call it, I'm going to look at my map. I'm starting in moles. There's moles, I'm starting here, and they want me to find grams, so moles to grams goes this way. I follow this arrow, and I see molar mass on the top and 1 mole on the bottom. I remember that the molar mass is different for each substance, so I have to use the periodic table. That's like we did with assignment E10.4, if you need a review on that. E10.4 will help you. So remember, that's only the case with grams, either direction. Okay, so molar mass on top, 1 mole on the bottom. So I'm going to add that 1 mole, because that's easy. Molar mass for lithium, I need to use the periodic table. And so I look for lithium, and there it is, 6.94 grams. And that's it, because then moles will cancel. And now I multiply across the top and divide by the bottom. .29. Now never leave your numbers naked like this with no unit. You got to use the unit from the wanted that we converted to. Moles canceled, and now our answer is in grams. And it's still lithium if you want to add that. There's the answer. All right, let's do the next one. How many atoms of lithium are in 3.5 moles of lithium? So this time it looks like the given is still the same, but this time they want me to convert to how many atoms. The words how many and what, things like that, a question that tells you what you want to find, what you don't know yet, but you want to find. Now always start with the given on the left. Times a fraction, see, exactly like before. And then I have to use my map. So I'm going to start with moles again, and this time I'm going to atoms. Starting in moles and moving to atoms. Here's atoms. So notice I'm traveling this direction, so it's this fraction. Now this time I'm not going to use molar mass, that's over here. So I just use this number the way it's shown there. Remember, moles will cancel because above and below, so that's a double check that you did the right one. And then we're going to use our calculator. Clear? So 3.5 moles times 6.02 second E23 divided by 1 equals 2.107. I'm going to round that to the nearest hundredth, so it's 2.11 times 10 to the 24th. You have to include that at the end. And that is atoms now. All right, next one. How many moles of nitrogen are there in 67.2 liters of nitrogen at standard temperature and pressure conditions? All of this is kind of extra stuff just to let us know that we can use this number on the mole road map. So how many moles of nitrogen, that how many makes me think, that's what I want to know. And are there in 67.2 liters of nitrogen? All right, nice. Always start with the given. Oops, I didn't put the G there. For given. All right, 67.2 liters. Always next is a conversion factor. I'm starting at liters on my map and I'm moving to moles. So when I look here, I find liters up here and I'm going 2 moles and I see that that arrow going that direction is this one. So it's 1 mole over 22.4 liters. All right, and then liters are going to cancel, which makes me happy because that's what I want. I want to change from liters to moles. 67.2 times 1 divided by 22.4 equals 3, and the unit is moles. That's the answer. And it's moles of nitrogen if I want to add that. I forgot to do that before. Same here, lithium for that last one. All right, remember you can stop anytime, but we're going to keep going. So, or I'm going to convert 2.75 moles of sulfur dioxide gas to grams. All right, it looks a little different this time. The given is coming first. I know it's the given because it already has a number, and they want me to convert it to grams, and so that is my wanted. All right, and it's SO2 or sulfur dioxide. Okay, I take the given, always the given, use the unit. You can put the substance, times, and a fraction. All right, then I'm going to look, I'm starting in moles, and I'm going to grams. So starting in moles, moving to grams. Oh, there I need that molar mass again. So a little bit extra work here. Notice the molar mass is on the top, the mole on the bottom. I'm going to write the mole on the bottom before I forget. And then I need to figure out molar mass. Remember, that's from the periodic table. So this time it's a compound. So I'm going to write it over here like we did with assignment E10.4. For sulfur, the molar mass is 32.06. There's only one of those. I'm going to add that to the oxygens I have here, 16.00. But there's 2 of those, so times 2. And so when I add these up, I think I can do it in my head, 64.06 grams per mole. So I'm going to put 64.06 grams here, because that's the molar mass, equals. Then notice, again, above and below, cancel. And now I can do the math of this part. 2.75 times 64.06 divided by 1 equals. I'm going to round this to the nearest hundredth again. 10th hundredth, look at the next place. It's 5 or above, yes, so I go up. 176.17. And the unit is grams. And it's SO2, but for sure, at least, you got to show grams. All right, 2 more. How many molecules of carbon tetrachloride, CCl4, are in 3.2 moles of CCl4? So again, my given is going to be green. I see the number, so I know that one's the given. That's where I'm starting, and what I want to find and change to is molecules. So I'm going to write the given over here, 3.20 moles, and I know I'm starting with, oops, I put CCl4, and then I always have a fraction. So I'm starting in moles, and I'm trying to get to molecules. So here we go. No molar mass to do. That's kind of nice. Just copy this number and just like it is there, 6.02 times 10 to the 23rd molecules, 1 mole. Moles are going to cancel. All right, and I type it in. 3.20 times 6.02 second E23 divided by 1 equals. Now 1.9264, I'm going to round to the thousandth. So 100th, 10th hundredth, go to the next. The thousandths is higher than 5, so I go up 1.93, but I also need to include the times 10 part, times 10 to the 24th. And the unit is molecules. All right, remember molecules are just like individual things, but we still should say what we have here, not just a number, but what are we counting there? Molecules. How many moles of nitrogen are there in 112 liters of nitrogen at STP? Remember that part's kind of just extra. Don't need that really. So I see a number with a unit, that's going to be my given. How many moles? That is my wanted. And I'm going to write the given first over on the left. And I guess I could put nitrogen, but at least the unit. And now I'm thinking about, I'm starting at liters and I'm going to moles. So I'm starting at liters and I'm moving to moles. So I need that one. 1 over 22.4. 1 mole over 22.4 liters. Liters will cancel. Remember, they have to be above, below. So you know you've set it up right when you see that. Clear. 112 times 1 divided by 22.4 equals 5. 5 what? 5 moles. Liters canceled, moles are what's left. All right. I'm just going to go back and remind, you can stop anytime, remember. Remember the given units were at what we started with and what went on the bottom. And so, like, here's a given unit and they cancel, right? Always the given cancels out because we put it on the bottom of the conversion factor. So I'm going to just add the color again here. And the wanted units always end up on the top of the conversion factor. And then that is what our answer is in. So those match. So atom matches atom. Moles and moles. Grams and grams. Molecules and molecules. Moles and moles. Okay. Follow the pattern and you will do fine.